Hello and welcome to part 4 of lesson number 3, the final part in Unit 1, Functions in our grade 11 University College math class. This is domain and range. Quick recap, we looked over sets of numbers in that we'll need to learn about different sets of numbers when we are articulating our domain and range. We learned that domain deals with all of the x values that are part of a given relation or function, and the range deals with all of the y values that are part of a given relation or function. We learned via number line how to sort of articulate what the domain and range would be. We learned about set notation, and then we started working on domain and range simultaneously in a variety of situations. We did 3 introductory graphs here, one that was continuous for real numbers, and 2 that included single points, which were part of the number set of integers. We did a couple more examples down here. We're going to do a final few examples, and then we're going to call it a day on this. So let's jump right in. First off, I want you to note that this last shape requires you to add a couple of arrows at the bottom here. I've already added them in. But down here, I want you to get some arrows on there. Since this is obviously a parabola, and we are going to go after the domain first. So let's go after the domain here. Again, what I'd like you to imagine is that we are going to be taking our function, which is or our relation at this point, could be a function, and we are going to be squishing it down against the x-axis along the way. Well, obviously this whole section here is going to be filled in. And then you've got all these parts here kind of coming up, so obviously this part here is going to be filled in. And what's interesting is these arrows indicate that this thing's going to kind of keep going down forever and ever and ever and just inching outwards forever. So this thing is really going to keep going all the way out to positive infinity in that direction. And similarly over here, we're squishing it up. This thing's going to go, because it's going to go down to, eternity, forever. It's just going to keep getting wider and wider and wider over time. We are going to have a line that goes out forever in this direction. So after we tidy that up a bit, a little tidying going on. Let's get rid of those, but keep the arrows. So what is our domain going to be? Well, what kind of number set is it going to be? It's a continuous line. So we're going to be dealing with real numbers, but it doesn't really have any limits on it. It's going to go out in both directions forever. So as we write our domain in set notation, we would say, that's an eraser, the set of all x such that x is an element of real numbers for our continuous line, and there's no limits on it. So we just shut her down. We just close up the set, and there you go. Those are nice and easy. We want more of these. And let's look at the range now. Similar idea. We are going to squish all of this function up against the y-axis as we go all the way along, down, down, down. So we can see there's a point right here. It includes 3. That's 3. And then it's going to go all the way down. It's a continuous line, so we've got all these little pieces in between going with it. This nice continuous line. Now, because the arrows at the bottom of our parabola keep going down forever, so will our range. So let's tidy that up a little bit. There we go. So 3 is kind of our high point, and then there's really no low point going on. So we want to make sure we get that in our range. So we would write the set of all y such that y is an element of continuous lines, so that'll be real numbers, where, because we only have one limit, which is a high-end limit, everything's going to be sort of less than or equal to 3. We can just put a single down and call it a day. So it reaches and includes 3 and everything less than that. But we're never going to get 4, 5, 4.2, any of that stuff. Nothing larger than 3 ever. Now, is this a function? Well, as we did before, we have a graph, so we can do a vertical line test. So as I'm growing, putting lines through this, I'm hitting once, 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 forever. And this pattern, like I said, is just going to continue down sort of in this direction. So it will never hit more than once. So yes, this is a function. Yes, it is a function as it passes the VLT. Passes the vertical line test, which means that when you draw a vertical line through the relation, if it hits 0 times or once only per vertical line, then you have yourself a function. So there you go. We're going to look at 2 more examples, and it's going to hopefully just broaden your definition a little bit about what constitutes domain and range for certain general types of functions that we're going to be looking at in this course, which are straight lines and parabolas. So let's start with the first one here. The first one is y equals 2x. Now, for us to really get this under control, we got to get it on the graph, I think, and hopefully that will shed a little bit of light. So y equals 2x, if you recall, this is in slope y-intercept form where you have y equals 2x plus 0, which means that we're going to be starting at our origin, and for every one we go over, we go up 2. Our slope is 2. Let's get some dots on here, and I'm going to draw a line through them, hopefully, all the way to the bottom. Kind of, sort of like that-ish. That'll work. Okay, so again, because I'm just putting these values on based on how I graph, it would actually be a continuous line. And I know I made a distinction about this earlier on where you're given a table of values. We weren't given a table of values here. We were given an equation. And this equation, I picked values to graph, but it would include, or could possibly include, all the little things too. It could deal with 0.1, 0.6, 1.3, 2, 2, 2, 2, 2, 2, 2. Like, it'll include all the values you could imagine. So again, if we're talking about articulating the range for this, if you can imagine we're going to be or the domain I should say, if you can imagine we're going to be squishing this down all onto the x-axis, squish, 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 off we go. So what we're going to find, don't want to erase the line, just that little green one, there we go. So we are going to see something that goes all the way out to this direction, in this direction, forever, and goes out all the way in this direction forever, since this shape is going to go out, or this line is going to go out forever in both directions. So how do we write down that domain? Well, that would be the set of all x, such that x is an element, continuous line of real numbers, but no limits. Interestingly enough, if we were to do the same thing with the range, where I were to squish all of this stuff, whoops, wrong direction, squish all of this stuff down onto the y-axis, so I'm just squishing it over there, you're going to have that same thing where you are going to have a continuous line that goes up forever all the way down to down forever. Up forever, down forever. So if we're writing this as our range, we would write this as set of all y, such that y is an element, continuous line of real numbers with no limits on it. So this is something that hopefully we're going to be able to build on, where this is a straight line. Obviously you can see it. We've drawn ourselves a straight line, and it has a wide open domain with no limits and a wide open range with no limits. Let's have a look at the parabola. And I'm just going to erase the domain and range that we sketched on here so that we sort of got a clean slate to work with. All right, there we go. So we are now going to graph, I guess, what colors do I use for this? I use green and purple, so let's put an orange one on here. So we're going to graph a parabola now, and the parabola is y equals x squared plus 1, for those of you who remember. That means that your vertex is going to be at 0, 1, and our plot pattern is out 1, up 1, out 2, up 1, 2, 3, 4, and from the vertex out 1, 2, 3, and up 9. That's up here and up here. So we've made ourselves a nice little parabola. I'm just going to sketch the line in. Again, we weren't given just points, we were given an equation. Now I've chosen to plot these points, but it's just as relevant to have, instead of 0, 1, 2, you could have had 0.6 or 1.993. You can have any little values in there you want, which is why we've drawn a continuous line. Okay, same idea here. Let's imagine our domain. We take this whole orange function and we squish it down against the x-axis. Now again, these arrows mean it's going to keep going up forever and ever and going wider and wider. So what we're going to end up with, eventually, if you were to follow this relation far enough, it would completely fill the x-axis, all the little crags and crannies. So what is the domain then of our parabola? The set of all x, such that x is an element of real numbers, no limits. Just goes off forever in both directions. Lastly, let's have a look at our range. So let's tidy up my drawings here a little bit. There we go. And now we are going to imagine we take this parabola that we've got and we squish it up against the y-axis. And as I do that, I see that I have this actionable point right here at 1. And then as I squish it, it's going to go all the way, because this relation is going to keep going up forever. We have this nice continuous line going all the way up forever starting at 1. So we do have a limit here. Let's articulate that in our range. So we'd start by saying the set of all y such that y is an element continuous line of real numbers where y will be, we're going up, so those will be larger numbers, so greater than or equal to +1. And there is your range for a parabola. Again, something to notice here is we're going to be dealing with parabolas a lot in this course, in Unit 2 specifically. Yeah, we're going to be looking at a lot of these and talking about domain and range. So what you'll notice for this parabola that opens up, or one that opens down, it's going to have a domain that's wide open with no limits, and it's going to have a range that is limited only by the vertex. So there you go. That's domain and range. I know it's a lot. I wanted to take my time explaining it. I know this was a really long series of videos. Jump into the homework. If you have any questions, reach out. You can get me email in class or in our online video chat. Ask me lots of questions. This is one of those big new concepts you're going to be learning this year. And good luck with the homework, and good luck with the Unit 1 assessment.